Hi guys, welcome to the channel. Today we'll be discussing about the design of pad foundation. Are you ready? Come on, let's go. Foundation design. Foundation design. Now we'll be designing 3 foundations, but they will be on a separate videos. There is a reason and there is a purpose. So we'll be going into pad foundation design. Okay, now before I go into foundation, there are things I have not shown you guys. Okay, in the last video I was not able to import the column details, so I'll do that quickly. I'm very sorry for not doing such thing. Okay, so we have finished this. So after generating our calculation sheet from this area, you come to details, you come here, story 1, you click OK. This is columns for story 1. Please note, if I copy this, let me just do it so that you can understand what I mean. If I copy it to my environment now, you'll see what will happen. You see it? See what happened to it? See how it's scattered? Alright, I wanted to show you. So what do when you get this? So when you get your columns, like the first thing you do, please explode it here in AutoCAD. Explode it. Now it has exploded. I cannot copy it to that environment where I'm saving my works. I cannot copy it now. You will find out that it will not be scattered anymore. Okay, do you see it? So that is what you'll be doing in all the things you'll be bringing into this environment. Ensure you exclude it before taking it in, so as not to give you a big problem. Alright, so we go to the next one. We bring the second columns out. Okay, so the second column, so explode it, highlight X, enter, it will explode, or you use explode icon here. Okay, I copy. Alright, click, I copy. I'm taking them to one environment immediately. I don't need to begin to waste time doing another video on how to take it to one environment, so that you get everything in one video. Okay, alright, we save. Then the next thing we need to do now, I didn't teach us how to export our drawings. Okay, so before I go into foundation, let me quickly do it. So to take this your drawing, this drawing to AutoCAD, you just come here, you click DXF. This is what it's going to save. It's saving in my master class. Okay, now look at it. Please explode it as well. Explode it as well. Alright, so you cannot copy it. You cannot copy it. Cannot paste it. Save. So we are going to bring out the second floor because they are of two different arrangements also. So we'll save this one as well. Explode it. Highlight it again. Then you copy. You now paste it in this place. You click save. I've gotten my members now. I have my slab, I have my beams, I have my columns. These are the major things we needed. Okay? Alright. So to go into my foundation design right now, I will not be making use of this ground floor nor the first floor, but rather I will go and make use of the foundation. Now if you look at this place, you will see STOO, you see STO1, you see STO2. STOO is foundation, STO1 is our first floor, STO2 is our second floor. Is that alright? So I click on this STOO. These are the columns. These are all the columns in that our drawing. Now we are to design the column base of all this drawing. Now two things I want to point out is this. Please take note. You can practice it, you can try it and see how it works. If I highlight all these columns now, if I highlight all and design it, it will have the same size of column base. All. What does it mean? It added the load that is coming on this building and divided it equally to every column. Very, very dangerous. So I don't encourage that. So you don't design all. You design one by one so that you can point out the load coming on this particular column, so as to know the choice and the area provision of the reinforcement, because and the section also very, very important. All right, to design the column base, if I want to design this column base, I'll draw my arrow across like this and I leave it. It highlights. As it highlights, I right click. I want to design pad base. As I right click, I go to insert pad base. It brings up this for me. Please, some of this information is going to be given to you by people that do soil tests, soil scientists. If they work, if they have done soil investigation, soil test, they should be able to give you the soil allowable stress, that is the soil bearing capacity they give to you to put here. It's very, very important. And if they don't give you, depending on the area you are designing, based on the literatures and books you have read so far, even Oninoga pointed out so many of them in his book, areas like so in the southwest, you can use so thing based on the practicals and experience so far he had. Say southeast, you can use so if there is no one, so as to know exactly or not to be too far from the assumption. Right? So the lesser the bearing capacity, that means the type of foundation anyway. If the bearing capacity is too minimal, you are to go use another choice of foundation, either pile or raft. But if the soil bearing capacity is good enough, then you go for pad. Right? These are the factors that one need to consider before choosing type of foundation to be used for his for his building or structures. Now, footing depth, you know that in the real experience, in the real practice, we are told and we are taught that our footing depth should be at least 450. That is a size, a height of a block, when you stand a block, a height of a block should be our footing depth. But so many people compromises. So many people, they will put 300. So many people will put 200. No, that foundation is very, very important. Very, very important. I'll talk more on that when we go into detail, so that you understand why you should not compromise any standard. All right. Now, temper height. That one, I don't understand what I say. So charge height is only 700. Even while you're in school, you are taught that. Now, soil unit weight is this. Okay. Now, allowable this is this. Okay. Now, you can decide to adjust this one to 450, or you can leave it at 400. At least it's reasonable. So concrete cover is 40 for foundations. All right. Now, these are the steel bars. These are the steel bars. They are telling you to use Y16 at X axis as E16 at Y axis. All right, no problem. Now, this place is our moment at Y axis and moment at X axis, but it has not is not showing here. It has not been activated so far. And remember that this is software. And I say this, that when you are using software is a programmed application. You are not supposed to be going with manual. If software with manual, then is no more a complete software. Software should be to give you everything, provided is programmed by engineers, because everything that you needed is supposed to be put in place. I can see the reason why I should be using software to be working, and at the same time I'm using pen and paper and to be calculating, and there's no need of using the software anymore. Software should be able to generate things for you. That is why it is made to make work easy. It is made to fasten your job. It is made for you to be able to do a lot of job, multitask yourself with a lot of things. So if it demands you going into practicing again with hand, then that is not complete. Now, may I say this? So many people are saying, I need protest structure, I need this, I need that. My brother, is because you don't understand how softwares work. ORION software, protest structure software, they are the same. Now, if you have checked into these softwares, you find out that these companies, if they stay for a very long time, they look for another means of making money. That is what is happening today in our phone industry, in our telecommunications. Somebody will bring S2 for you, in the next 3 months he bring S3, and if you check, there is no difference. So why changing all these things? People keep on running from this to this, saying it's upgraded. My brother, maximize that first one, utilize it. You know, most times I find out that there are errors in the next upgraded one, because they need to test run it, they need to work on it. That is why you see ORION, you have ORION 14, you have ORION 15, you have ORION 18, you have ORION. Now ORION 18 is the last ORION that will come out. Prota has taken over. Now, if you check, 16 has some small limitation. Maybe it wasn't able to do this. That is why it's upgraded, incorporated those things and make it another version. Now this 18 is the last ORION version that is coming out. Now, that is to say that there is no other upgrading of this reinforced concrete software of ORION. Now, what they did now for people to still patronize them is to incorporate steel, and they cannot incorporate steel in ORION and say call it ORION. People will still not value it, so they incorporated it and they give it another name, Prota structure, with incorporation of steel. If you open the Prota structure, exactly what you are seeing here is what you see there. Why will people say I need Prota, I don't need ORION? You see, that is a misconception. And if you have been using ORION software, you know ORION software very well, you don't need anybody to teach you Prota structure concrete design. But so many people are deformed. That is why. So I don't jump from one software to another. I learned this, I use it very well, I utilize it before going to another one. Understand? That's what I do. All right, now let me go back to what I'm saying before. This moment here has not been activated. You can see there is no load, there is no moment, there is no moment, and you have to put moment must be here for you to design. So what do? Now look at this arrow here. Try all column combination. Bring this arrow down to anyone. Bring it down here. It has come out. You see, this is the load now, this is the moment. Have you? All right, at this point we can now calculate. Look at what it's telling you. The column base size will be this. So many people will alter it here, but I don't need to alter it. I go with what this is giving me because this is program. So I believe that is correct. I check what is giving me here, check everything is okay. Punching check is okay. S direction okay. Share okay. I see in it, everything here is okay. So why should I? And I say okay here. I click okay here again. It has inserted it. Look at what it gave me. 500 by, this is 1000 by 1000 column. 1000 by 1000 column. So this is how you design your columns, all of them. You design your columns, all of them. Change what you need to change. Now look at no moment here. Take it up, bring it down. That's all. Change your other things. You calculate. See your grade of concrete you are using. See the grade of steel, everything. Now say okay. Designs. You can see this base and this base is not the same. Now listen. Why they are not the same? This is edge. This column is at the edge here. This load is coming this way and this one is coming this way. Now half of the load here coming like this, going to this column, half of this load going to this column, right? Okay, now this column is suffering more. Why? Half of the load here is coming to this column, half of the load here is coming to this column, half of the load here is coming to this column. So why is it not? Why is suffering? You can see it's suffering. Now when you come to column like this here, this column is suffering more than this and more than this. This column will have a load coming from this area to this, coming from this area to this, coming from this area to this, coming from this area to this. So the column is suffering. You see the reason why I said in those days our grandfathers they would go and put big columns at the edges, thinking that that is where the load is coming from. But you can see that the inner columns are suffering. They are the ones that is bearing the load, not even these ones outside, not edge ones. They are the ones suffering inside. Can you see it now? So if you go and carry 300 column and put here, and carry 150 column and put here, it means that you don't understand structural design. So continue like that. That's how you design all of them. You design them one after the other, one after the other, one after the other, one after the other, one after the other.
Okay.
one after the other. Now you can design, you can do combined footing. You can design 4, 5, 6, 7, as the case may be, columns together, and you group them together because maybe the way they are placed, the way they are positioned, you can maybe is not allowing for single. You combine them together and you design them. How do you do that? I'll show you. People have not been able to teach. I found out that teaching is very, very difficult for people because they want to hide what they know. But the world is too big. If I teach you well, it does not mean that I will not get to work again. The world is too big. After teaching you, I don't know where you will be. So why will I be disturbing myself? I will not teach you. I hide this one, I hide so that you can come back to me. Please, if you have such knowledge, discard it. If you want to teach anybody, teach the person all you know. All you know. Half knowledge is dangerous. Half knowledge is dangerous. If you want to collect money, tell the person the amount of money he or she will pay. Be sincere. If the person pays you, teach the person. Please. Don't hide knowledge. It has not paid anybody good. When I was in school, I taught a lot of people. And today, I'm still working. I'm still getting works. So, that does not mean that if I teach them, I will not be able to do work again. No. The world is very large. The world is very large. Alright, I want to show us how to design double footing in case you have such one. Though these columns here does not mean double footing anyway, but I will show you something. Let me design this one as single. I will show you. You see something now. Right, let me assume that these columns are too close, that I want to do combined footing. I will highlight the two. I'll right click. I'll go to combine selected columns. Now it's asking me a question. Separation, it says the separation limit where bending of the base between the columns and local punching shear conditions can continue to be ignored. Please consider whether it is appropriate for the second member to be considered as a group with a base designed as a single footing according to rigid base theory. Do you want to continue? Because it's not saying the columns to be grouped. It's too far to be grouped. If I say yes, you will see what will happen. It will still permit me. I continue. I will now go back and say insert add base. Just be watching. I don't want to use it to show us something. Just be watching. 900. Okay, you can see. You can see the difference here. Okay, this same column is this type of column. Now let's design this one as one. Let's see if one works. I'll use that one to show you how to design double footing. In case you have double footing anyway, it can be 3, it can be 4. You highlight all of them at the same time and do that at it. Right, click it first, go to combine footing, then you go to the next one. Okay, you can now see. Now I have 1002 here. I have 1000 here. Have you? Now I have 1009 by 1009. Now, for me to construct this column, it's going to cost me more than constructing this column. Number one, this column is going to carry double basket up and down, but this single column is going to carry single basket. Number two, this is 1,2, this is 1,000. The volume of concrete that will be used for this column will be more than the volume of concrete that will be used for this column. So why should I go for this when I can have it single? You know, it is advisable that for you to do double footing, the difference between the two columns should not be more than 600. If it's more than 600, design it as a single footing and see what happens. But if it is lesser than 600, combine it and design it. Because if it overlaps, okay, now this one didn't overlap. If this overlaps this now, and I leave it like that, and I want to use this exactly the way it is in the site, it means that this column, this base, and this base will be. So the best thing is, if two of them is overlapping, is not to combine it, but you can see that we are still okay with what we have designed. So always consider economy in your design. It will help you. Okay. It will help you. Okay, now you can see it. I finished the design and I have different column bases. I have different column bases now, and I want to get the calculation sheet now. Okay, I can wait. Let me export it first. Take it to AutoCAD. Now I want to get the calculation sheet for all these columns here. If I click on this one, the base, if I click on the base, I right click, I go to print pad and pad result, I click it. This is the calculation sheet for that column base. You can see it here. This is the calculation sheet for that column base. Of course, you know that everything was okay. When you check it, punching, share, everything okay. They are okay. If it's not okay, it will come out. You will see it here, not sufficient. By the side, it will write it out for you. The one that fell, it will write it out, not sufficient by the side here. So anybody that pick up this report, you don't even need to look too much. You just see where it's right, just the way this thing come out like this. That's how it will just come out, not sufficient. So you cannot hide it. All right. Now this is single. We made this one to be single. Now we want to get all of them. We want to get all of them the same time. So as I click on this one, look at all my foundations has come out. All has come out, Abby. So I click this one. I hold shift. I click the last one. It will highlight all of them for me at the same time. So after highlighting, the thing will change to square as normal. And I right click and I say print the report. It will not print all of them at the same time. So it will not print all the report at the same time for me. See that 20 pages. So it printed all at the same time. So it's better like this. It's better for me like this, okay? So you can take time to look at them very, very well. Cool, and save it. Save as. Save it. And close. Now, the next thing we need to do is to get our column bases. The column base detail. Column base details. Column base details. To get my column base details, I come here. Foundation details. Look at where I'm clicking. Foundation details. I click here. This will appear. Remember, I clicked here. This foundation details. This appears. Now I have to create another sheet for these things I want to paste now. So I click this new detail sheet. New detail sheet. This is the size it's bringing up for me. So this one doesn't matter, but if you don't do it, you'll not be able to bring out the details. So just choose any one of them. Then these are the squares. The more you reduce this scale, the bigger the detail. If you increase these squares, the smaller your detail. Okay. All right. So I click OK here. Now look at my cursor has turned to square. This one that is highlighted, if I click here now, it will come out. You can see it. This is the column base for this one. Look at it. Alright, I want to bring the next one. I click it. I take my mouse inside. I click, it will come out. I click the next one. I take my mouse inside. I click. That's how you click all of them if you wish. If it's me, I don't need to bring all of them. I'll just click few of the ones I will use for my drawing. But for you, you can bring all of them out for now until when you get used to the system. Then you know how to do the rest. So that is it. You will bring them out. Click. You go inside. You click. You click. Go inside, you click. You click. Go inside, you click. You click. Go inside, you click. Alright, you can still bring it down. continue. Click. Alright, so this is all. Okay, you take it to AutoCAD DSF, you export it. You explode there. That is all. Okay, we go back to our drawing. You can now, if you want to cut section here, fine, you can still cut section. Just click your section, draw a line across, and click it, section, look at it. You can still cut section if you want. Alright, now let's go back to our normal plan. Okay, let's check our 3D so far. Alright, you can make it only 3D here, so let's check. Hi guys, I've come to the end of our Pad Foundation design class. The next will be the Rat Foundation and the Pi Foundation. And I know you find value in our class. Therefore, don't forget to like our video, subscribe to our channel, and on your notification button so that you'll be notified whenever we drop a new video. And if you miss our last video, please look at the right hand of the screen, click and watch. See you in our next class.